video we'll be looking at 6.2, inverse of a function. Definition. Let f be a function the inverse of f often denoted with the symbol f and to the negative first power, we simply read this as f inverse, is obtained by reversing the coordinates in each ordered pair. In the function f. Okay. Example. Let's say function f is determined by the set of ordered pairs 1 pairs with 2, 3 pairs with 5, and smiley face pairs with question mark. Alright, if this is f, then f inverse is simply the function 2 pairs with 1, 5 pairs with 3, and question mark pairs with smiley face. You see I simply reversed the x and y elements of each one. Let's look at an example how we will use this to deal with our XYZ homework. For the following one-to-one function, and we'll get a definition for one-to-one in a second, find the equation of the inverse. They give us the function in function notation, f of x is equal to 2x minus 1, and they ask us for the inverse, and we call this f inverse of x. Okay, they're asking us for the inverse. Well, the first thing we will do is change this from function notation to equation notation. So instead of saying f of x is 2x minus 1, I'll say y is equal to 2x minus 1. These two statements are analogous. F of x 2x minus 1, same as y equal 2x minus 1. Well, I want to find the inverse. In order to find the inverse, I'm simply going to exchange my x and my y. That's what I did a little while ago. So exchange x and y. That's step 1. So rewriting this equation such that x and y are exchanged, I have x is equal to 2y minus 1. That's step 1. Step 2, solve for y. So I want to solve this equation for y. I'll begin by adding 1 on both sides. On the right side I have 2y. On this left side I have x plus 1. Now dividing by 2. On this right side I have y. Here I can divide both of these individually by 2. X divided by 2 is x over 2. Said another way, it's 1/2 x. And 1 divided by 2 is 1/2. Okay. And I certainly could have left it in this form here. So I want you to compare our initial statement with this statement. This is saying we're going to multiply x by 2 and then subtract 1. This is saying we're going to take 1/2 of x. Notice that's the opposite of that. And then we're going to add 1/2. Coming back to this statement, you can see it a little clearer. This statement and this statement are the same. This is saying add 1 and then divide by 2. This is saying multiply 2 and then subtract 1. You can see that those statements are exactly the opposite. Here we are multiplying by 2. Here we are dividing by 2. Here we are subtracting 1. Here we're adding 1. Those are inverse operations. I'm going to examine the tables for each of these. So for my initial statement, x and f of x, for this table here, 0 pairs with -1. And if I substitute 1 in there, 2 times 1 is 2, minus 1 is 1. Let me substitute 2 in there. 2 times 2 is 4, minus 1 is 3. Okay. Now separately, let's look at x and the inverse. Well, this is my inverse over here. I'm simply going to rewrite this as f inverse of x. All right. 1/2 x plus 1/2. Now I'm going to take these y values and substitute them in, and you'll see it's going to pair with these. So I'm going to use this first y, -1. Substituting -1. 1/2 times -1 is a -1/2. -1/2 plus 1/2 is 0. So here you can see 0 goes with -1. Here -1 pairs with 0. Now here 1 pairs with 1. It's going to do the same here. Substituting 1. 1/2 times 1 is 1/2. 1/2 plus 1/2 is indeed 1. 1 pairs with 1. Now I'm going to substitute 3. 1/2 times 3 is 3 halves. 3 halves plus 1/2 is 4 halves, which is 2. When x is 3, f inverse is 2. Here 2 pairs with 3, here 3 pairs with 2. So you can see that effectively this function reverses the coordinates of this function. So when we're asked to do this, first step we exchange x and y. Second step we solve for y. This initial function we call f of x. This new function we call f inverse of x. All right. Definition: one-to-one function. A function is one-to-one if every element in the range, that's our outputs. Generically we use y, comes from exactly one element in the domain. In the domain, those are our set of inputs. Commonly we use x. Okay. I'm going to use this shorthand mnemonic. There will be, for a one-to-one function, we won't have any repeated x's or y's. No repeated x's or y's. This is taking a little liberty with the definition, but it'll be generally an effective way to remember this. Let's look at an example and a non-example. Example of a one-to-one function would be this. We'll have our domain being 1, 7, and 9, our range being 4, 5, and 6. Here you can see it satisfies the definition of a function. Each x goes to only one y. There's no repeated x's. But also it satisfies this new definition. That is, each range element comes from exactly one domain. 4 is only coming from 1, 5 is only coming from 7, and 6 is only coming from 9. Notice there's no repeated x's or y's. Here's a non-example. Counterexample. Let's say our domain is, again, 1, 7, and 9. Our range is 2, 5, and 2. Okay. This is a function. 1 pairs with 2, 7 pairs with 5, 9 pairs with 2. Each x goes to exactly 1 y, but it does not satisfy this new definition. Every element in the range comes from exactly one element in the domain. 2 is coming from 1 and 2 is coming from 9. So it does not meet this definition. And you can see we have this repeated y here. All right. This, while it's a function, is not one-to-one. Graphically, a one-to-one function will satisfy both the vertical and horizontal line test. Vertical and horizontal line test. A function not a one-to-one function, but a function will pass the vertical line test. Recall from our earlier definition of vertical line test, the vertical line test states that if we can draw a vertical line through any part of the graph and it only touches at most one time, then that relation is a function. If it touches more than once, it's not a function. Now, a one-to-one function will pass the vertical and horizontal line test. All right, quick example. We're going to call this parabola here function f. Okay. It is a function because any place we draw a vertical line, it only hits once, passes vertical line test. Okay. However, it fails the horizontal line test. Most places I draw a horizontal line, I'm going to hit twice. Here I would hit twice. What you're seeing is this value, this y value of 0 comes from two different x values. Thus, it fails the horizontal line test. Okay. Fails horizontal line test. So it is not one-to-one. All right, that concludes the notes for 6.2.